discuss both generalized and conditional inverse. So the outcome of this topic, okay, you can find the conditional and generalized inverse of matrix A. Okay. First of all, when do we need the generalized and conditional inverse? Okay, so what is invertible matrix? Okay, you can inverse a matrix. First condition, the matrix A must be a squared matrix, which is n by n, and uh, although matrix A is square, it must be a non-singular. It must be a non-singular matrix, where the determinant is not equals to 0. Okay, so there are two conditions for a matrix A to be invertible. First squared, and then it is non-singular, which is the determinant does not equal to 0. Okay, so what if your matrix is non-square and or it is square but it is singular matrix? Okay, what if A is not square and singular matrix? So for this case, we need generalized and conditional inverse. So this is the properties of inverse matrix. So if you have a matrix A, the multiplication of A and A inverse will give you an identity matrix. And similarly, A inverse dot A will give you an identity matrix. Okay, so this is the properties of the previous inverse that we have learned. Okay, but for generalized inverse, okay, let A be an m by n non-squared matrix. Okay, if a matrix AG is the generalized inverse of A, exists that satisfies the four conditions below, we shall call AG a generalized inverse of A. So, okay, the first one, AAG is symmetric. Okay, and number two, AGA is also symmetric. The third one, AGA will give you A. Okay, so A inverse A will give you A. Okay, so ini AAGA also will give you A. Okay, number four, AGAAG will give you AG. So the generalized inverse of A is also called as G inverse of A. And then we have another type of inverse of A, which is C inverse, or denoted by AC. Okay, properties of AC is AACA equals to A. Okay. The G inverse of A is also a conditional inverse of A. Okay, but conditional inverse of A may not be the G inverse of A. Okay, sebab G inverse of A ni unique. One matrix can have only one AG, but one matrix can have more than one AC. So if you get AG, that is AC. But if you get AC, maybe that is not AG lah, sebab AC ni not unique, ada banyak AC. Okay. A conditional inverse exists for each matrix, but it may not be unique. If A is m by n, conditional inverse is n by m. G inverse pun sama, kalau A is m by n, G inverse is n by m. Okay. Generalized inverse of A. Okay. The first one, theorem, A be an m by n matrix of rank R. Okay, the G inverse of A can be computed by the following steps. So, the steps lah. Tapi this is the main formula to find AG. Okay, so to find AG, you need R, where R is the rank. Okay, R is the rank of A. So you need to reduce A until row echelon form. Okay, CR depends on R. If your rank is 2, so you need C2 here. And this one, tak nampak, this is A transpose. Okay. And this one is the trace of CRB. Okay. So what is B? B is the A transpose dot A. Okay. B is A transpose A. And then C, kalau R kita 2, so we need C1 and C2. Okay, we need C2, but C2 needs C1. Okay. So C1 is always identity matrix. But what is the size of C1? It depends on B. Kalau B 2 by 2, C1 2 by 2. If B 3 by 3, C1 is also 3 by 3. Okay, I is the identity matrix. C1 is always an identity matrix. Okay, and to find C2, C3 and above, we will use this formula. Okay, for example, if you need to find C2, C2 means that your I is 1. Okay, so this is, if you need to find C2, your I is 1. So this identity multiply with 1 over 1 trace C1b minus C1b. Okay, if you need to find C2, so C3 for example, so your I is 2 here. So I 1 over 2 trace C2b minus C2b. Okay, so the higher your rank is, the higher, the longer your solution will be. Okay, so a G inverse of m by n exists and the order is n by m. Okay, if A is a null matrix of order m by n, okay, its G inverse is the null matrix of order n by m. Each matrix has G inverse. Each matrix has a unique G inverse. Unlike C inverse is not unique. Okay, A transpose G equals to AG transpose. The rank of G inverse of A is equal to the rank of A. The rank of A is defined to be the number of non-zero rows ataupun number of leading one after we reduce the matrix of A. And AGG equals to A inverse the inverse matrix, we get back the matrix A. Okay, if A is non-singular, then AG is equals to A inverse.